Okay, so I just wanted to show a little demonstration on how to fill out, find the end behavior of a polynomial, just so you can start on today's work. So over here we have the polynomial y is equal to 6 minus 2x plus 4x squared plus 5x to the third. I just want to put this first in standard form. Now this right now is not in standard form because we see our exponents, they're not in order. So I have to go ahead and rewrite this. So what I'm going to do is I'm going to have y is equal to, bring that down, bring over the 5x to the third, put negative x to the second right next to it, put in the negative 2x, and then put down that positive 6, okay? So now that that's in standard form, the only thing that I need right now is this chunk right over here, this first term with the highest power. And from this chunk, I'm looking for the degree and the leading coefficient. Now, when I'm talking about degree, I'm talking about this exponent right over here. So when I fill this out, I'm actually going to write 3 for the degree. Now, we have to look for the leading coefficient. And the leading coefficient is just this number right in front, this 5 right over here. Okay, so when I fill that out, since this is just asking for sign of LC, you can write either a positive or a positive 5, right? And now that I have the degree and sign of the leading coefficient, I can go ahead and describe the polynomial's end behavior using my chart right over here. Now, the way you want to read this is first look at your leading coefficient. This is a positive 5. And my two options here is the leading coefficient is a number that is greater than 0 or a number that's less than 0. 5 is, a positive 5 is greater than 0. So I'm going to be using this top part of my graph. Okay. Now I have to look at degree. So my degree is 3. So 3 is an odd number. So I'll actually be looking at the odd degree here. So this section is now specifically going to tell me all I need to know about that end degree. So when I fill this out, as x is going to negative infinity, I just have to look over here. This is positive infinity. Okay, my negative infinity is right down here. As x goes to negative infinity, y is going to negative infinity. So I'll write that. And all this is saying is that when we graph it, on the left side, your polynomial is going down. Okay, and then over here, we have x is going to positive infinity, so that's over here. My y will also go to positive infinity. And this is just telling me that right, it's going up. Now, what I mean by those directions is that if I actually drew out this graph, like sketched it out, we're going to have something where, oh yeah, oh, and I just want to label up my axes really quickly. So my x-axis, this is where all the negative numbers are at, the negative infinity, so negative 1 to negative infinity, and this is where all the positive numbers are, or the positive infinity. With the y-axis, my positives are up here, and my negatives are down, are like going in the down direction, okay? So when I'm actually drawing this out, using end behavior, left, I'm just going down, and then right, I'm just going up. So it'll have around this same shape. And I already know that it has to be the same shape because when I think about back to back to these right over here, these give me a little like idea of how your function is going to look like with certain degrees. So a function with a degree of 3 is going to have this like N shape or this upside down N shape. A degree of 2 will have that U shape. The degree of 4 will have that W. And the degree of 5 will have like around something like this. Now in the worksheet that we're looking at, that we're filling out today, you'll be doing the same thing. So you're finding the degree, the leading coefficient, and you're just describing the end behavior. Down here, for questions 9 through 12, we're just trying to match the polynomial function with the graph. So we can actually do this without a graphing calculator. All we need is that that first term. So right after you made sure it's in standard form, you just want to get that first term with the highest exponent, and you're going to see, right? It has an even degree, it has a positive leading coefficient. So what does that mean when you actually graph that out? Okay. Does it mean that one of the ends, the end on the left is down and the end on the right is up? Does that mean both ends are down, both ends are up, or the left is up and the right is down?